you were to go through and define the gas laws. What pressure is, what standard atmosphere is, what torr is, what absolute zero is. Okay? And then you were to find out what the relationships between all the pressures were. We did go through that a little bit last time, where 1 atmosphere is equal to 760 torr, is equal to 101.3 kilopascals, is equal to 10.4 psi, all that. Okay, so that's where you put all of them equal to each other, and that's actually in a table in your book, and I also went through it on the video. Then you were to take 28.6 inches of mercury and convert it into atmospheres, torrs, psi, bars, millimeters mercury, and kilopascals. You're going to need to divide it by whatever inches mercury was, which was 39 or something like that, and times it by whatever the number in front of these were for the conversion. Then we went to convert the following temperatures. This is where you use 273.15 and you add it to your degrees Celsius, or you subtract it from the degrees Celsius. Then as we went to 6.7, we actually went into the laws. Now, these are things that I would put on my 3x5 card. Okay, let's put the phones away, please. Thank you. I would put Boyle's law and Charles' law and the combined gas law and the ideal gas law and what is STP and what's the conversion between atmospheres and torr, and I would put those all on my card. Then I gave you a couple of problems to try, and I'm going to do one of these with you because I did one with last period. And so which one would you like me to do? 4, 5, 6, or 7? 6. Okay. So we're going to do 6. Covering up my pretties here. The first thing to do with any of these gas laws is you need to identify what you've got. It's a story problem. So as you're going through, you're going to identify what you have. So a still tank with a volume, here's V1, is full of pressure, here's P1. What is the volume in liters the gas would occupy? So I'm looking for V2. If the pressure, here's P2, is this. So I don't have any temperature. So temperature's held constant. And if you'd watched the video last night, temperature held constant is whose law? Boyle's law. Good. So I did have some watch it. So Boyle's law is P1 V1 equals P2 V2. So I don't have V2, so I'm going to solve for V2. You can do it one of two ways. You can plug in everything right now and just put an X for V2, or you can rearrange it. I prefer to rearrange it, but you can just plug in and then solve, and that's fine too. So plugging in 3.25 atmospheres times volume, 6.25 liters, divided by pressure 2, which is 0.250 atmospheres. At this point, atmospheres cancel, and we're left with liters. And we have 3 significant figures. So we punch that through, and what do we get? $81.3. Okay. Now, anytime that I hit a temperature when I'm in the gas laws, I need to get it into Kelvin, so I'm going to add 273. This Boyle's law did not have a temperature. Up here in number 4, we have a temperature, so make sure to add that and get a final temperature before you plug it into your problem. She will have it where it's not got the 273 added, and the answer that you get will be there, but it will be wrong. Okay, so make sure that you add the 273, because that is a very common mistake. Remember that STP means standard temperature and pressure. So what is standard temperature and pressure for the gas laws? And what's that? So that's temperature. What would be the pressure? 1 atm. Or since they're working with torr right here, I would probably want the 760 torr. The only time I have to be in specific units is when I'm working with the ideal gas law. Okay, so these here would be my T2 and my P2, and as I go through, I'm just going to show you on this first one. I like to circle what I have and identify it. Find out what I have here. I would put it in my calculator. That would be temperature 1. Find out what I have here is pressure 1. And then I'm looking for volume. So I'm looking for V2. That's my question mark. And so this one has all of them. So this is what I would use here as the combined gas law, because it has P1, V1, T1, P2, V2, T2. So it looks like this. And then I would solve for V2. That's the combined gas law. Okay, so you need to be able, she has a lot of problems where you're going to be needing to identify what law you need to use, plugging into that law and finding what you don't have. Okay, there are a lot of them on there. Okay, so let's go on a little bit to the next area, the ideal gas law. The ideal gas law is what? PV equals nRT, right? Ideally, you're not a pervert, right? That's how I remember it. PV equals nRT. Ideally, you're not a pervert. Okay? So that works really well for that one. Okay, so, yes, ma'am. Avogadro's law is when you hold pressure and temperature constant, but you change the number of moles with volume. Uh-huh. You change the number of moles, and that affects the volume. Okay, so on the back here of that page, we had a bunch of problems that we could do with the Pervnert equation. So I will do one with you. Which one would you like to do? A, B, C, or D? C? Okay, so the temperature in degrees Celsius of nitrogen gas sample that has a volume, so I've got some kind of temperature here, and a pressure of 300 torr. Should have circled my volume. Okay, and it contains this much of a mole. So I know PV equals nRT. I'm solving for T on this one, so T equals PV divided by nR. R is a constant, R 0.0821 atmospheres times liters divided by mole times Kelvin. So plugging in, I need to first, before I plug in, is with the ideal gas law, it tells me what unit each thing needs to be in. And if it's not in that unit, I need to get it in that unit before I use the ideal gas law. So pressure is not in atmospheres. To get it in atmospheres, I need to divide by 760 torr and times by 1 atmosphere. So we need to do that. So let's find out what the pressure in atmospheres is. Should be like 0.4 something. Somebody throw that through and give me 3 sig figs. .395. Okay, so now I can plug in. Everything is in the unit it needs to be in. So 0.395 atmospheres times the volume, which is 2.50 liters, divided by the moles, 0.100 mole, times the constant, Now that bottom one I need to remember needs to be in a big parenthesis when I go to hit the divide sign. Canceling out the units, atmospheres go, liters go, moles go. I've got 1 over 1 over Kelvin, which will give me Kelvin, so let's get that far. $120. Okay, now to get back to Celsius, I need to subtract 273.15. So my degrees Celsius is going to be a negative number, right? And the 120 is where my significant figure is. So what have I got for an answer down here? Negative 153. So and I would just leave it like that and drop the 0.15 because I only have 3 sig figs. Okay, so you got to be able to plug and chug and get it through. Okay, there's a lot of plug and chug in this one. So let's go on to the next part here. 6.9 is Dalton's Duh law. Dalton's Duh law just says the pressure total is equal to all the little parts added up. Okay? Hi. What do you got? Kylie? Yep. Traffic ticket. Okay, so on this one, a lot of the kids last period said, we just don't get how to do this. Even though it's the Duh law, they were having a hard time. So which one would you like to look at, 3 or 4? 3 or 4? 4? Okay. So I have this sample of gas, and it's collected over water displacement. We're actually going to do water displacement next time in a lab. So as a result, the oxygen is saturated with water. The partial pressure of water vapor, is equal to 22 torr. Calculate the partial pressure of oxygen if the total pressure equals 720 torr. Well, I know pressure total is going to equal pressure of water plus the pressure of oxygen. So the pressure of oxygen is going to equal the pressure total minus pressure of the water, right? So 720 minus 22, and the unit still is torr. So 698 torr is the pressure of the oxygen. Done. Okay. So even though they gave me a lot of things, as long as I know the total pressure and every other pressure besides the one I'm looking for, I can find it. Okay. Then we get to the next law, which is Graham's law, and that takes us through the 610. That we were supposed to watch last night. So 610 is Graham's law. Who can tell me what the difference between effusion and diffusion is? And there was silence. Effusion is through a hole. So like if I have a gas pipe and it has a hole in it, I effuse through the hole. Once it effuses through the hole, it diffuses through the room. So effuses through a small hole, diffuses through a big area. Okay. Graham's law is basically the rate that one is moving divided by the rate that another one is moving is equal to the square root of the molecular mass of the B one divided by the molecular mass of the A. And we're actually going to work with that in lab today. So As we work with this in lab today, what we're going to do is we're going to go back in the back room, and we're going to grab some straws, and I'll take you back in small groups. Each of you are going to grab, after you grab the straw, you're going to grab a Q-tip, each of you. And you're going to insert it and mark where it goes to. And I should probably use the colors we're using. We're going to use red and black back there, so I'll make that. So you're going to put them in, and you're going to mark how far you put them in. You don't want to put them in so far that the second cotton ball goes in, okay, second cotton side goes in. But you want to put them in so that when you move it, it doesn't fall out. Does that make sense? Okay, so once you get that marked, you're going to come to the hood with me. And then on this side, we're going to have a container that has hydrochloric acid in it, and it has a dropper in it. This is concentrated. You do not want to get it on you, so it's in the hood. We're going to do it in the hood. On this other side, we've got a container, and it has NH4OH in it, and it also has a dropper in it. You're going to take, and you're going to actually take your cotton ball, and you're going to take the dropper, and you're going to touch the edge of the dropper to it till you soak that edge of that cotton ball. Okay, this one on this side is actually one of these dropper bottles that has a little tip like this. So you're going to just touch it and do it. This one isn't because it's gone bad. It's just a regular dropper. Once you both get it saturated, I'm going to be holding it from the top like this. So here's my little thumb in the back. Okay, I want you to hold it from the top too, because if you hold it from the bottom, if there are drips, they're going to drip on you, and you don't want that. You want the drips just to go into the hood, and we can wash them up later. But you don't want to get them on your skin. So hold it from the top. So each of you are going to come in, and you're going to hold your part from the top. And that's awful little hands, but that's okay. You get the idea. Okay? You're going to insert these at the same time. So you can count 1, 2, 3. You're going to insert them. Okay? Once you've done that, you're going to turn and go back to the lab table, which is black. And you got your Q-tips in here. Okay? And you're going to watch, and pretty soon, a very faint white line will appear. This white line is where these two have met and actually have made ammonium chloride. Now you got to watch carefully. So you're going to be rolling this slightly back and forth, and I would be touching it only here on the ends. This is my little fingers touching it on the ends to roll it. Okay? So that I can see that little white line come right when it comes, because once it starts to show, then what starts happening is it starts to grow, and it doesn't necessarily grow evenly. So you got to get it when it first appears. So I'm going to go back to where I first appeared, right here, and I'm going to mark it. Then I'm going to take it to a ruler. Now our ruler's back there. It's really hard to measure from the end here because you don't know if it's right at the metal or if it was in a little bit before. So I would take it and I would line this one up on the ruler with the 10. Okay? And then you can measure out how far it is from here to here that it moved. And you're going to write it down on the front page, at the bottom on the right-hand side. Then you're going to measure from here, from here to here, how far did this move? And you're going to write it down. This will be the HCl, how far it moved. This would be the NH3OH, which turns into NH3 vapor when it moves and leaves water behind. Okay? Then we're going to come back in and do the calculations. I'm going to take you back a couple at a time. Okay, so basically 2 at a time. After I take the 2 back, then the next 2 come back after about 5 minutes if they haven't come back. Okay, and then we'll be able to rotate you through. You need goggles when you come back. You do not need aprons. It's your choice if you want to wear an apron. It's not going to be back there very long. When you're all finished, you're going to slide these all the way in and then throw that away. Okay, I trapped it inside. That's why we do it in the hood. okay? And we do very small amounts. They've done cotton balls before in big glass things, and that takes a long time, and then you got to worry about it. But we use small amounts. Okay, so what I'm going to do is the exit quiz is a little bit different this time. Like I said, she does a lot of problems on the test, and I wanted to give you one like every single problem that's on the test. And so I've got to give you 10 problems. Well, that means 10 workout problems. So I'm going to give it to you now. I'm going to put the clicker quiz up so you can click quiz it. It's 2 pages, but it's not both sides because I couldn't copy it both sides with my printer. I want you to show me your work. I want you to put your name on it. I want you to staple it and turn it in because I'm going to check your scores, and if your scores suck, I want to be able to go back and see what you did. Is it just a matter of you didn't put it into your calculator right, or is it a matter you're really not setting it up right, you have no idea what you're doing kind of thing? I want to be able to go back and look at it. Now, if you have not watched the video, you can go back and fill in the rest of your stuff by either watching the video tonight, grabbing the book and going through the book part of it. Next time is going to be a quiz on the next videos. Okay, so you need to make sure you're ready to roll. If you don't have time to watch the videos, grab your book and go through the book. Fill out your notes on what's in the book. Okay, so don't just not do it. I'm trying to teach you some skills that will help you when you get to college. You can't show up unprepared to a class. Okay, and there was a lot that did today. So we need to make sure we're on top of it and we're not doing that last minute trying and purge to get past the test. We need to know it. All right? You guys are all so quiet because you're getting stripped down with me today. Got to be on it. We really need to be on it. We got to push through the end, endure to the end. Okay? All right? All right. Then we're going to move on.